So, good evening, everyone. Before going to the actual topic of systematic review and meta-analysis, I just wanted to make all of you aware about there are few prerequisites. Whenever you think to decide to conduct a systematic review, so what all you need to have with you in advance. Okay. So actually systematic review is like any other primary study. Here what we do study of the earlier conducted studies. So we do the study of earlier conducted studies. So for systematic review and meta-analysis to conduct, you need to have a team with you. Okay, just a single person cannot do a systematic review, because as per norms, you need to have more investigators with you. So what all team you need to have? You need to have like at least 2 persons for screening the studies, earlier conducted studies. A subject expert is needed, a statistician is needed, or someone who is having a fair experience of systematic review. This can be done, and after having a team, you need to decide the topic, and here also you need to have a specific research question that is not answered yet. Though the study on a particular topic has been conducted, but there must be some lacunae or something or the other point is missing, so that you need to have a well-defined research question in advance, on the basis of which pertaining to the objective of those research questions, or you need to conduct your systematic review to answer to those research questions. And then what is another important thing? It's a robust study in which you need to look into various database system in order to answer the research question. So by definition, is systematic. This is a systematic collection of relevant primary papers in human population that deals with the focused question and includes a summary of evidence from the primary resources. So now I explain, like, it's not like we cannot go haphazard here. Like a narrative review, we do, we make a framework. Narrative review is like writing an essay, whereas a systematic review, we have to go step by step in a systematic way to collect the data, to chart down the data from the primary papers, and to gather the summary of that data, and to analyze that data and draw our conclusions. So as I said, traditional review is like there are so many chances of bias in the traditional review, because it's like writing an essay in which the thoughts of the author also go inside that their own. But whereas in systematic review, that problem is not there. It's free of bias, investigators bias. Okay. So in traditional narrative review, authors pick and choose the study they discuss, and then in depth in which they want to discuss them. There is no defined protocol. Okay, so another prerequisite of conducting a systematic review is that in addition to a research question, you need to have a research protocol also with you in priori, so that you need not to deviate from that protocol and maintain that till the very end of your conclusions. So you need, but for narrative review, you can pick the paper, you can choose the paper, any of the paper you choose, the thing you want to include, in whatever depth you want to include, you include them and draw your conclusions. Whereas here you need to have an itemized data collection that you have decided. Okay, so what is the difference between systematic review and narrative review? narrative review is a non-specific, and that narrative reviews has lots of chances of bias, whereas systematic reviews are specific, comprehensive, and explicit. And in systematic review, we have to have defined criteria, or since they have defined criteria, so chances of bias are less in systematic review, or minimum as compared to narrative review. And the systematic review also are very, very rigorously done studies that require lot of input. So one need to have lot of time in their hand to conduct a systematic review, because, and other important thing, because you need to go systematically through primary studies, so the person should be well versed with, have a good knowledge of critically analyzing the study, means their reviewers skills should also be very good. Okay, here for systematic review, quantitative and qualitative. For quantitative, both type of data synthesis are then done. For narrative review, only quantitative, up to quantitative data synthesis is limited. And sometimes narrative review also inferences are maybe evidence based, but systematic review is for evidence based synthesis. So various definitions. Systematic reviews are the scientific investigation with pre-planned method or protocol and an assembly of original study as their subjects. They synthesize the result of multiple primary investigations by using strategies that limit bias and random error. Now let me explain all this to you. So as I already said that what is a systematic review? Systematic review is the study of earlier conducted primary studies. So it's a scientific investigation, and the reviewers here are known as investigators. They have a predefined protocol in advance that should be already preferably be registered to various sites. I will show you the sites also. And then they assemble the original study. As like in primary study, what we do, we enroll the subjects, and then on those subjects we do our study. We analyze the data, we pool the data, we draw our results, we draw our conclusion. Here, instead of individual subjects, we enroll the individual studies in our, and then based on those studies results, or based on those studies conclusion, we draw our data from those primary studies and synthesize those data, and investigate and organize our results and draw our conclusion based on the analyzed results. So systematic review helps to avoid the personal bias inherent in the traditional review and expert opinion. Why? Is because the systematic review have defined criteria. On these items we are going to collect our data. Now, in narrative review, you can draw any line from anywhere, and you can go up to any depth. But in systematic review, what type of data we are going to collect are already defined. You have to have a template on which you collect your data. That template I will share later on. So for conducting systematic review, as I said, you need to have a team. So when you do a database search, then there will be so many studies that will pick up in your search. So many hits, known as hits. So many hits you will get in your research when you give your keywords, and so many hits you will find over there. So at least 2% should try to find out the relevant study. And then now 2% that recognize those 2% are also we need to whenever we write our systematic review, we need to give in text also that such and such person, that how many persons has gone through the database searches like Smita Sthana, maybe Seema Singh. So SA and SS conducted the primary search from the databases. So that sort of sentences should be incorporated in systematic review. It's not just like you have conducted and you have not defined. Defining those things are also very, very important. Okay. So if you go through any earlier published systematic review, you will find that they have mentioned the name and this sentence that who has conducted the systematic review, primary database searches. So hypothesis, I already said that your research hypothesis or your research question should be defined and conceived at a priori. So then comes, why should we go to for such a tedious jobs? Why should we at all we need to conduct a systematic review? Because day in and day out medical literature is expanding a lot. So too many trials, and if you go to PubMed search and then you search for, there are too many studies that are published per day. So as a common person, it's very difficult to go through all those studies. So if someone in a single paper is giving gist of all the relevant, important, and the studies that are having good quality, that will be a very good source of like medical literature to the reader. So that's why, that is the reason we need to conduct a systematic review. That's one reason. And other reason, there are so many clinical trials that are already conducted and then the result that are not reached to the doctors, and then no one maintain that database so properly. So if we conduct a systematic review, all the important literature, all the earlier important existing study, they gist of that the research question came out, and then medical practitioners can utilize those things in their private practice. So another thing is, like, sometimes the studies that are conducted may not have a sufficient power, or sample size is less in various studies. Maybe clinical trials, they require lot of funding is required to conduct a clinical trial. So the sample size usually is less. So by pooling the various primary studies, what happens? Ultimately, the power of the study get enhanced, and the value also get of that particular interpretation or conclusion also get enhanced. So systematic review identify, appraise, and synthesize the research-based evidence and present in a accessible format. So all of us are aware about this triangle and the evidence synthesis. So systematic review and meta-analysis comes at the top. You can see over here, even above the randomized control trial. Why? That I already said that it requires a rigorous methodology. Such, for example, I said that at least 2% should involve in conduct of such. 2% should involve in making the collecting the data. I mean, extracting the data. Then how these persons, whether their data is coming, these 2% are usually blinded to each other's whatever they are doing, and then they see whether the results are similar or dissimilar, and how the similarity dissimilarity deals, that they also need to define in there. And so the methodology of these systematic reviews are very, very rigorous. Secondly, that I told you that the person who is analyzing the study, who is going through the study, should be a person with having some knowledge of how to review. So the studies should be peer reviewed, and ultimately it acquires a large sample size because of the pooling of that data, and the only high quality evidences are taken into consideration. Like mostly cross-sectional study, these are those type of study, case study, etc., omitted out. And if there is some lacunae and lapses in the conduct of primary research, so we don't include in our systematic review to strengthen the conclusions that we are drawing. So to because it's an evidence-based synthesis, so quality of evidence need to be high. So the systematic review ensure the high quality of the evidence. So sometime we also need to contact the author for any detail of data of the study. So supposing a primary study, you are getting in public domain in PubMed search, you are getting a good study, but the data that you need to be included is not there, or you want raw data. So you can always write to the author or the person who is conducting systematic review, take the data from there. So we conducted a cervical cancer screening program, HPV screening program at Dadri. So the author of 2-3 times we were asked to provide the raw data for those studies, because the author want to include our study into their systematic review. So see, so how much inputs are needed to conduct a systematic review? You need to contact even the authors of the study to get the data from them. So numbers are, you can see in this that how many exceedingly number of the systematic review and meta-analysis are, and these things are getting popular day by day. So what should be the characteristic? So I already said that predefined. So I already said that there should be a predefined research question. So when the research question is predefined, so automatically objective and title must also be predefined. You need to have. Then that was regarding the protocol, the title, the objective, the research question that are like a primary study. You need to have defined at priori. In addition to that, you also need to define what are the eligibility criteria for your study. Okay, so you go through the things and you see that authors give different eligibility criteria, whether you are going to include observational study in your systematic review or not, whether you are going to take cross-sectional study or not in your protocol, or you are going to take cohort study, include cohort study in your protocol or not. Okay, what should be the minimal sample size, what should be the language, what are the outcomes variable, and what should be the comparator that you are going to include in your study. Okay, and what should be confounders that you need to, if those confounders are not adjusted, then you will not going to include that study in your systematic review. So all these criteria you need to predefine. Then explicitly reproducible methodology. What does it mean? It means like whatever you have, like I said, whenever you are two persons are conducting the database search, you need to define. Then what are the key terminologies you need to utilize to for the retrieval of the primary studies? Like in PubMed search, what are the key terminologies, keywords you have used? What are the dates on which you have conducted the search? Okay, that is also important, because as the time passes, number of studies keep on increasing day by day. So whosoever, if someone wants to see what are the what are the hits coming on that date, that person must be able to do that. Apart from that, the number of included studies, the number of excluded studies, the reason for excluding the studies, particular study, that also defined. And there is a method of defining all those, charting out all those, that will come later on. There is a Prisma flow chart that also you need to have. And apart from that, what are the relevant sites that you are utilizing? That whether you are using only published data or unpublished, ideally whatever literature is available, whether it's a published or unpublished, whatever you try to include from grey literatures, etc. And then justify the criteria for exclusion or inclusion the study. Analysis of methodology, risk of bias. So I think risk of bias, etc. This I will tell you in more detail. Just be familiar with the terminologies, because I know few of the things you might not be able to understand, but later on when I explain with the help of example, I think you will be able to understand. So, apart after you need to define how you are assessing the quality of your included study. Clearly analyze the results of the eligible study, and statistical method of data meta-analysis. Then if meta-analysis you are including what type of meta-analysis, there's a fixed approach, model, random approach, whatever you need to define, and then structured report of the review. So as I said, systematic review conduct is a stepwise process. So I said that you need to have a title. Title, what is a title? Title, by now you must be familiar, like title should reflect your research question. So title is formulation of the research review question or research question. So because approach is here adopted. So what is that? P stands for patients, intervention, C for comparator, outcome, and S study design. So you need to have a formulated research question. Why? To finalize the objective, to determine the eligibility criteria, and it as well as it's also needed for searching of a study and collecting of data from included study and presenting the finding. Because once you start conducting a systematic review, unless you have everything defined in front of you, okay, research question and objective, and then unless you have everything defined in front of you, you will get confused if you don't have a everything defined in the form of a protocol in front of you. That's why it's very, very important to have a defined criteria in front of you. So this P stands for, I said, population or a patient or problem. I will give examples also. Intervention. Intervention means either intervention or exposure. Comparator means this versus this, means drug A versus drug B. Outcome, what is the outcome? Whether the person get cured and what was the success rate or something like that. So with the help of example, I will explain what is this. And of course, S is not here, a study design. So here, P stand for what are the patient of interest. Is there a particular age group, gender and or population? So like for primary study also you define all those things. Here also you need to define what are your subject of interest or your population of interest. Is there, are you conducting your study in older age group? Are you conducting your study in younger age group? Whether you are going to conduct your study in rural setting, whether you are going to conduct your study in urban setting, whether it's in male only or female only, things like that you need to decide. And what is the health concern? For example, for patient entering the healthcare facility. So these are your patient whosoever is entering a healthcare facility is your population of interest. Then what is the intervention or exposure? What intervention? Intervention means extenuous, whatever extenuous thing you are introducing, or whatever exposure is naturally coming. For observational studies, exposure, or interventional study, for clinical trials or interventional studies, intervention. So what therapeutic, diagnostic, preventive, or other healthcare interventions are you interested in knowing more about? Okay, whether HPV vaccination is good in 30 to 50, in 10 to 20 year age group, or 30 to 35 year age group. So your intervention is HPV vaccination. Okay. So that is the intervention. What healthcare management studies are you interested in comparing? So maybe HPV vaccination versus cervical screening, pap smear screening. So you are healthcare. These are the healthcare management studies that are your interventions. Okay. So for person entering here in this example, the intervention is given in red color. For patients entering in healthcare facility, what is that? That is P. Okay, or patient is hand rubbing with waterless alcohol based solution. So intervention is rubbing your hand with waterless alcohol based solution. So that is the intervention. And then what is the comparator? Comparator, is there a comparison to evaluate against the intervention? Or only if more than one intervention, or if no intervention is a factor? For example, here for this example, for persons entering in a healthcare facility, is hand rubbing with waterless alcohol based solution, that was our intervention, as effective as standard hand washing with antiseptic soap? So what we are doing, we are here comparing the alcohol based, waterless alcohol based solution with standard hand washing with antiseptic soap. So you are comparing two things, alcohol based solution and antiseptic soap. And O is outcome. What is the desired outcome to be evaluated? Outcome is what? Here in this example, outcome is given. How will the patient or population be affected or not affected by this intervention? So for the same example, for person entering a healthcare facility, what is that? That is P is hand care rubbing with waterless alcohol based solution, is I as effective as standard hand washing with antiseptic. So this is the comparator for reducing health contamination. So outcome here is hand contamination. So reduction in hand contamination is your outcome. So this is a research question. So what the investigator is need to collect all the study that are conducted on this topic from various databases that are available to them, and then move further. That gradually I will take up. Then another question, is aspirin effective in primary prevention of cardiovascular disease? Okay. So here, those who are having cardiovascular disease are your patients. Okay. Aspirin is your intervention. Okay. Outcome is primary prevention of cardiovascular disease. So in two groups, those studies in which aspirin one group given, and comparator is those who are not giving aspirin, means with aspirin, without aspirin. Okay. So this type of research question drafted with all these things in place. Okay. Healthy adult, aspirin, placebo or intervention, CVD events. So this is given in tabular form. So now development of a review protocol. So first step was formulating a review question that I already said you need to have a PCOS model to formulate a research question. then then how you are going to search and select your study. Because I said that this is a study of earlier conducted primary study. So how you are going to search those studies, and how you are going to select the eligible study from that. This need to define in your research protocol. Then what will be next? Study quality assessment. Okay. So those studies that you have selected, that you found eligible, is their qualities good enough to be included in your systematic review, or they are of poor quality, you need to exclude them. So how you are going to assess that study quality of the included study? So here you need to for individual study, you need to do the quality assessment. Then comes how you are going to extract the data from the study. So what are the variables that you are going to, on basis of those variables you are going to extract the data? So what are those variables that you are going to extract from those individual study, and then data synthesis? So here, so how this was the searching and selecting study was the step. So search. So you need to develop a search strategy. Okay. And you need to specify time period that I already told you in your protocol. So for developing such strategy, I will tell you how we need to develop. So first of all, you need to see what databases are available with you. So here, one important thing is that if in your team, in your systematic review team, if you include a librarian also, then it will be very helpful. So apart from that, you need to have what are the databases available to you: Medline, Embase, Cochrane, Sinhel, trial registries, etc. And there are subject specific databases are also there. So a subject expert can tell you. These are some general databases that I have enlisted over here. So then apart from searching the electronic database, you can hand searching of key generals, cross reference also you can search. How that you can do, like if you find a relevant article, very relevant article, so that article might have contained various studies in there as references. They might have cited other studies. So if you find a very useful study, you go through the list of references and find that all the relevant studies that that person has included, whether you have included or not included. So that is one thing. Other thing, if your similar topic, someone other has conducted a systematic review, earlier systematic review, so you can make a list of those studies that are conducted by earlier systematic review, that the authors list you can, or the reference list you can make, and then ultimately whatever studies you are getting, whether everything is included in your study or not, or whether you have missed out anything, that all then and there you can compare, and something is missing you can include here at this in your study. But you need to keep a record of all the studies, from where, what type of studies, how you are going to search all these things. And then subjects experts are also there. So from subject expert, you can also do a personal communication to see whether what type of things, whether you are missing out something. That's why it's important to include a subject expert in your systematic review of that particular question. Like if you are conducting a cervical cancer screening study, so maybe Shankar Narayan, you included him also, and you can show him your protocol, you can show him your things also, take their opinion also, if possible. And then in your protocol, you need to define if some paper, foreign language paper is there, whether you are going to include that paper or not. So including a foreign language paper is a very, very difficult task, because you need to translate that paper, and then you may have resources, and you might not have all those resources. So how you are going to deal that, whether you are going to include those foreign language study or not. So if you don't have resources, there is no means. Then if you are not including those studies, you need to define in your this thing that you are, or any foreign language paper, your article, you are going to exclude. In your exclusion criteria, you need to define that. Gray literature, unpublished literature, etc., you also need to define. Studies with negative finding must be difficult to get published. So then a meta-analysis of the published paper will give a positive result only. So that's why we look for publication bias, because mostly you see that it's a tendency that only positive, those who are showing some positive results, only those studies are have higher chances of getting published. So then in such case, we get the publication bias, and we need to have a key on that. So for that, what we can do, we can go to the clinical trial registry, see whether such type of study. You can contact the investigators, those who have conducted any such trial of your interest, and you can, if, and then nowadays they you can contact the publishers also, those who have not published such studies. So the pharmacology company also, they might have the data with them. So these are all things require a lot of efforts and resources. Suggest contacting researchers known to be active in the field of interest. Also, drug companies often have unpublished, that I already said. So nowadays, these drug companies are releasing these negative trials also to Cochrane and others. So to define a search strategy, I said, like, one thing is that you need to have a database. Then what you need to have a keywords. What are relevant keywords? I think by now you are aware what is keyword and how to conduct literature search in PubMed. Here in PubMed, we use these Boolean operators known as or, and not. Just to touch upon the point, what do you mean? It's shown in with the help of a Venn diagram. If you use or, here you see that this or is shown here. What does it mean? Means all, if you are conducting a search on breast cancer and screening, your research question is on topic of containing key terminology, breast cancer and screening. If you use this or, so it will include all the articles pertaining to breast cancer and pertaining to screening. Okay. So here, if you use this Boolean operator and, so only those article will be selected that are having in their key terminology keywords as breast cancer and as well as screening. So screening here means there might be other disease screening also, maybe cervical cancer, oral cancer. So all those will also come here. Breast cancer and screening articles only will come, and not, so it will take all the breast cancer research and omit out screening. Not. So these Boolean operators you need to use in capital letters in between two key terminology. You use this. So I think in other lectures you might have taught about all these things. So I said, after I said for searching the database, you need to have a at least two investigators. For selecting a study, you need to have more than one observer, means at least 2 observers. Then these 2 observers, they are initially blinded to each other. So whatever result they are getting, then they see that is this result similar, or is there is some controversy or dissimilarity or some discrepancy in between these 2 observers or investigator. So how in such a case, if supposing you are getting 21 articles, you have selected 21 articles eligible, other person has 30 articles, so how these 5 articles will be or 5 citations will be you will deal with that. Maybe what is the strategy you resolve this disagreement? That strategy also you need to define then and there in your protocol. Say for example, I have given you example, SA and SS conducted the initial database searches, and the discrepancy arise was sorted out with deliberation or with in consultation with another senior author, maybe SL, senior third author, or some other person. They their inputs are also taken to resolve those agreements, and then that is the practical way, and also that is strategy you need to define in your protocol. And then other thing I already said, that you need to keep a log of your the excluded studies with a reason of exclusion. So how we'll show you, like in a Prisma chart, I will show you that this some sort of reasoning should be there. Okay. Define inclusion and exclusion criteria of the studies. Here also and evaluation of the data quality. Then after that you can do. So here again same chart. Are the studies eligible for a systematic review? So I said that eligibility criteria based on. So this is a step-by-step process. First step is to define your databases. Like you will do PubMed search, Google Scholar, and things like that, and the Embase, etc. And then after that, what will be your search strategy? Search strategy, keyword terminology, Boolean operator, and hand searches, whatever you need to write. And then after that, maybe you are getting 100 studies. So those studies are actually known as, defined as eligible studies, eligible for systematic review. So those studies eligible for systematic review, are you going to include those studies in your systematic review, or are you going to further select? So if these are not eligible, then you need to discard. And if these studies are eligible, then you need to go through the abstract of those studies. You know that study has 2 parts. First is abstract, then text. So first step is you need to go through titles and see, and you will get at least some idea that whether it's relevant or not. If not relevant, you discard, and then you go through abstract. By going through abstract, many of the studies, maybe 80%, 90%, you will come to know whether it's relevant to you or not. If not, if some reason is there with you find it's not using those observations that you want, their comparator is different or something different, so then you can discard those study, or otherwise you include those study and enter the data into a specific format. So this is the Prisma chart I was talking about. So here it's not visible. So search, initial search on, like here I have given you example of my paper, oral cancer screening. So risk of oral search for oral cancer is associated with smokeless tobacco use. So this was the hit which I got through this PubMed search. And this also included some articles which I retrieved through Google or Cochrane or whatever other data sources. If I have got some article, I have included here. And then through title screening. Step is to screen the title. Out of these 304 studies that are apparently non-relevant, they are title different, entirely different. Going through title, it was clear to you that this is not of my cup of tea. So you excluded those study, and a number you have written over here. These many studies excluded. So these many out of 4,846, 4,542 studies discarded due to apparent non-relevance. 304 studies, you have to go through abstract of all these 304 studies. So what will be the fate of all these included study that you go for abstract there? So then you, after reading the abstract, you discard those you feel that it is not relevant or due to any other cause. If any other cause is there, you note down over there, and otherwise you need to go through the full text of the study. And then here you need to define very clearly after full text that why you have not included those studies. Like here in this example, the reasons are given over. Study design was inappropriate. Quality was not good. Study design was not having comparator or something like that. Study mainly on pre-malignant lesion. Here my point was to see the malignant lesion, and the study was on pre-malignant. Proper control was not there. Small sample size, inappropriate estimates, and so on and so forth. Reasons you need to define, number of studies, for what reason, how many studies you excluded, you need to define. And here at this stage, also keep a reference list also with you, for because someone might ask later on why you have excluded this study or something like that. So you need to have reference list also. We preserve a list of excluded study also. Okay. Then study included in systematic review. Ultimately, there were 37 study out of 4,846 study that were included. So then comes the, after you have finally decided sorry. So that was the step where you have decided that these are the studies, maybe 100 studies you are going to include in your systematic review. Then those were the final 100 studies. Here in that example, there were 37 such studies that you decided to include in your systematic review. Then next step comes the data extraction. Okay, so here data extraction template should be, you have to have a proper template on basis of which, on that particular template, you extract your data. So this data extraction template you design, and then you pilot that data extraction template. So here again, data extraction is again done by two observers, separately and blindly. Method and topic expert to extract the data is essential, because the person who is not aware about the methods, who is not expert in the topic, he will not be able to understand. Okay, maybe supposing you are conducting maybe a drug trial, and you ask some person who may be a non-medical. He will not be able to understand the things. He will not be able to understand effects and all that. So the person who is having the knowledge of method also, topic also should extract the data. And then here again you need to express the agreement, whether they were in perfect agreement or there were some disagreement. And then here again at this step also, how you are handling those agreements and how you are coming to some agreement, the method by which method, like could be like a senior person or a third investigator or by deliberation, whatever methods you are using, you need to define. Then multiple reports of the same study, how do you handle? Sometimes there are studies that give interim result also, phase 1, phase 2, phase. So the subsequent phases contains the data of the earlier phases. Maybe earlier they have given data on 100 subjects, result of 100 subjects, then 150, then 200 subjects. So this 200 contains the data of 100 also. So if you include those study again and again, then what will happen? There will be the duplication of results of that study. So the study which is having maximum data, the recent most study and that most relevant, you need to use your investigator's skill to decide on how you are going to handle the multiple data. That also you need to define. And you can also, it's advised to obtain missing data from the investigator, because these days with electronic media, it's easy to approach the investigators. So data extraction has a template or a sheet. So describe the characteristics of studies included in the review. Enable and make the quality assessment of the study included in the review. Okay. Provide the numerical data of outcome which is necessary for meta-analysis. So here, can you see this example? This is an example of template. That's a first step to describe the characteristic of a study included in the review. So what could be the characteristics? The study year, study location, study design, sample size, okay, and how you have defined the age group, control, okay, what is the definition of case, what is the definition of control, what are the outcome variable, what are the confounders, comparators, and what are the estimates you are this type of data extraction template you need to have with you for various study. This is a published paper that I screenshot and put it over there for here reference. And then second step is to make quality assessment of the studies included in the review. Okay, quality assessment of individual study, that is known as to assess the risk of bias. For that, if you conduct a systematic review in Cochrane, or you use Cochrane this software, Revman software, so they have inbuilt risk of bias assessment table and graph that I will show you later on with the example. So that is the another step, second step, and here, and then the numerical outcome of data. Here you see that odds ratio of men, women, and total here is given. Maybe if you can give the odds ratio of total also, things like that. So this is the example of data extraction template that they have, rather than in the form of a chart, they have taken here also like this. So should we stop here for a break?
Yes, ma'am.
Okay.
So we will continue after, I think. Hello.
Yes.
Yes, ma'am. We continue after this, after 5 minutes.
Okay.
Okay.
Section. So you know about characteristic of the included study you need to include. Then you have to, what you have to do, you have to assess the risk of bias of the individual study. So here I have given you a screenshot of shot of this Raven software risk of bias tool. So how we assess risk of bias? So it's a interactive platform on which you keep on giving your things, because assessment of risk of bias you have to do, and the interactive platform will give you risk of bias graph and risk of bias table. So as you by now you might be aware about this. This is a randomized control trial. So what are the risk of bias in a randomized? What are the parameters on which you judge the risk of bias? Maybe whether random sequence generation, here you see in this random sequence generation was there or not, allocation concealment was there or not, blinding was there or not, participants binding was not. So these criteria you already need to define. So for on the basis of all these criteria that you define for assessing risk of bias, individual study you keep on adding, and you keep on including, and you are going to assess risk of bias. So here you see, here in this snapshot you see that it is left hand side general and risk of bias table. So there is a listing of the parameters on which you assess. So you have to click on here, you have to enter in each and every study characteristic of the individual study properties, on the basis of which you need to define whether what is the risk of bias. So for here, for each individual thing, what's not moving? Slide is not moving. Yes, it's moving now. So here, see, risk of bias, though that table was there, and this is for one study. That was general table. All you have decided those all these criteria that you select from there, and then you have to enter the individual study. So here at this platform, I cannot tell you about. I only can tell you about, show you snapshots so that you will get aware about this. See here at the bottom, there is a author name, Delhi Cioza 2004. So this is the reference of study, and these are the parameter of risk of bias. And in so here this column heading is bias, and then author's judgment. So here in this drop down menu, if you click on this button, there will unclear risk, and there are the three things: clear risk, unclear risk, and there is no risk. Okay, risk, no risk, and unclear risk. So या तो है या नहीं है, या फिर आपको डाउट है, हो भी सकता है नहीं भी हो सकता है. तो three authors judgment, then this judgment you have to take for this particular study. For this particular study, you click and you need to select what is your judgment, and support of judgment you need to pen it down over here, and then all these things you will keep on adding, and the interactive graph and table will keep on appearing automatically. See, this is the risk of bias table. So here, what these green lines, green dots signify, that is, there is no risk green. Red shows there is a risk, and then yellow mark shows it's not well defined, and it is unclear. The risk was there or not, it's unclear. And see here on the column labeling, you see you can see that whatever criteria you have taken, like random sequence generation, allocation, concealment, blinding, all those are charted down over here. And on the role labeling, what you can see, the reference of the individual studies you can see. So here each lines refer the risk of bias of individual study. Like here in this, you can see that this last study, T-list 2007, this study do not have any risk of bias because all are green. Okay, this first study has it's a like mix of risk of bias, 2 points, whether blinding of participants and personnel was not there. It was not there. Clearly, there was no blinding in this study. No, there was clearly no blinding of outcome assessment. See, you can see that red line means there is this is a perfect risk of bias. On question mark, whether allocation of concealment or selection bias was there or not, that was not defined in the that published study. So author could not judge, the reviewer could not judge whether allocation of concealment was there, or they have done it or they have not done. So there is a question mark. So the more the greener area, the more the this thing means risk of bias is less. The red more area means there is more risk of bias. So the if risk of bias is more means quality of the studies that you are including is not that good, because there are so many chances of bias. So that result, that the conclusions, that whatever you are drawing is not that much authentic. Okay. So here this is the example of individual. Here you can see individual study and individual risk of bias assessment parameters. So now this is the risk of bias graph. So here you see for individual parameters, all the studies are combined together. Okay. Here you cannot, you don't see the data of individual study. Here the data of all the studies are combined together, and at a glance, these tables are good that at a glance it will give you visual impact, how good or how less or more risk of bias is there in your systematic review. So later on, if the risk of bias for the previous this thing, for this thing, if some studies carrying many risk of bias, you can exclude that study because of it has high risk of bias. Okay. Now here you see that for all the studies, the adequate sequence generation has done by all the study. Okay. So this graph is self-explanatory. So all the parameters is given over here. Here you see selective reporting. These studies are not free of selective reporting. Incomplete outcome data addressed. Few studies, 50% more than 50% are studies have incomplete data address. So this type of risk of bias graph, and they give you can make this use of this Cochrane software, Evman software, and it give you automatically. You keep on entering your data, it will give you output, and that you can utilize in publication your. And then there is another scale that is known as Pedro scale. This scale is also used for assessing risk of bias. Okay, here the criteria are defined over there. So rather, if you don't have, this Pedro scale is also used for similar type of assessing the risk of bias. This is a qualitative way, this in which you have to go through each and every study and utilize this scale, and then on this scale, no risk, yes. On if risk is there, risk of bias there, where that here in this type of scale you can define um, your studies. Then these earlier two scales were risk of bias for clinical trials. Here also you see all that parameter blinding and allocation, concealment, these type of these parameters are there. So these earlier two risk of bias assessment tool were for clinical trial. Here for observational and diagnostic studies, okay, these scales are not used. There are another in this table, it's given over there. What for cohort studies, for case control study, cross-sectional studies, these are the checklist that can be used and given in the tabular form in your paper. Okay, so these are all the things, and references given over there. In detail, you can read this article and understand and utilize these scales in your research publication. So meta-analysis is a part of, once you conduct your systematic review, if you have to further do the quantitative assessment, meta-analysis is doing, you can do. Meta-analysis is actually pooling the data. Systematic review is the up to the qualitative drawing of the conclusion of the studies, included studies. Meta-analysis is the quantitative part of the data. So meta-analysis also always conducted on, first step is to conduct systematic review and then meta. So principles of meta-analysis, each trial is analyzed separately. So we need to draw conclusion, we need to extract data from the each clinical trial, and patient in one trial are never directly compared with those on the another trial. It's the result of the pooled result of one study is compared with the another. One trial is it's not like you take result of a study, one study, Seema et al. And another is Smita et al. You cannot directly compare. Pooled data of all the trials are compared with another. It's a estimate because it's a study of studies, not the individual subjects. Or here, how we do that we'll explain later. Summary statistics are collected or calculated for each trial. Each study is weighted so that some contribution more than other is to pooled. So each study, that if you are using 6 study, so it's not like every study is containing weightage of 1/6. So there are certain things which we need to decide on the basis of that. Like if some study has confidence interval, what type of if it's a too wide confidence interval, if sample size is less, then the weightage to that studies, we need to give less weightage to that study. So weightage for each included study is different for pooling of the estimate. So summary statistics are pooled together to give the meta-analysis. Later on, you will understand better when I explain with example. So why we perform meta-analysis, that I already told you, to increase the power, because the sample size increases when we pooled several studies, so power also increases. For improved precision of estimate, quantify treatment effect and their uncertainties, access consistency of the result. You can see what type of results are coming, whether they are consistent or not. And then those questions are answered which are not posed by the individual study. And then the factors that differ across the study. So there are various factors that are different across the study. So pooling of the data, somehow you are uniformly collecting the data and giving one estimate of those. If 10 study, you give one estimate. Okay. Settle controversy from conflicting studies or generate new hypotheses. So these are the these are the indications for which meta-analysis is performed. So what is the minimum number of studies needed to conduct a meta-analysis? At least 2 studies. Obviously, 1 study, so what you are not pooling any data. So at least 2 studies are needed. When characteristic of the studies are sufficiently similar so that it makes sense to combine them. Okay. Characteristics of the study are sufficiently similar. What does it mean? What does it mean? It means like the parameters that you are, the variables that you are including, there should be similarity in those variables. When the data is available in similar form, can need to combine them. You need to have outcome in similar ways. So in my example, in my Prisma chart, when I have given key, I've already excluded those who are having pre-cancerous lesions. Suppose you are doing a study on a cancerous lesion. So pre-cancerous studies you cannot include. So similar type of outcome. If you are calculating on cancers, so cancers you can calculate. If for a particular cancer, so that particular cancer study you can add upon. It's like maybe oropharyngeal cancer you are. So supposing you are doing study or pooled estimate of oral cancer, risk factor for oral cancer, maybe some alcohol use or something like that. So oral cancer, you cannot compare with oropharyngeal, because here the estimate is pharyngeal is also included. So ideally oral compare with oral. It's not the oral you can compare with oropharyngeal. Okay. So, but of course, like here, if you like, you cannot compare with apples with oranges, but some meaningful interpretation, if something is coming like that, you can compare that. So I will explain with an example, otherwise it's difficult to explain. Here in this, this is not that clearly visible, but here you can see, like here you see my cursor, pan, tobacco, betel quid, areca nut. So this is the study of oral cancer and various type of smokeless tobacco products. So here pan tobacco, betel nut. So these are individual tobacco product. Pan tobacco, etc. Betel quid, pan tobacco, जिसको बोलते हैं ना, pan betel quid is also same. Then oral snuff, snus, gutka, manpuri. Okay, nasal snuff. So I cannot compare between gutka and manpuri. That will be a wrong. But I can, if I give them all together a combined title of smokeless tobacco, then these things can be combined, because everything is a smokeless tobacco. Getting the point? So what comparison you are, how you are pulling the data, what type of outcomes you are combining, you need to be critically think over this and then decide. So you need to, doing meta-analysis, you need to define the comparisons, decide on outcome for each comparison, data retrieval, entering the pool data and explore heterogeneity and interpret the result. Define comparisons means what all you are comparing. Decide on outcome of each comparison, whether it's a odds ratio, whether it's a relative risk, it's a whatever outcome you are pooling, whatever means estimates you are pooling. So that outcome you need to decide. Data retrieval, how you are taking the data, whether you are taking data of individual patient or you are taking the data of the odds ratio directly. What data you are taking and how you are taking. You are calculating yourself or whatever given estimates given there, you are taking that also you need to decide in advance. Entering and pulling the data on the software, because these days manual data pulling etc. usually not done, at least we don't do. Then you need to see the heterogeneity. How you will see? I'll tell you. Interpret the result. So this is a snapshot of reference software. So here for this is example, that snapshot is here. You have to select from here, like here fixed effect model is taken, mental Hansel test is. So as a statistician, you need to know what type of test you are utilizing. Here selected odds ratio, and this is the way you can select and then go to next and generate what type of method analysis method you use. And then forest plot is created. The outcome that is visible is known as forest plot. Show you here why it's called as forest plot, because it shows visually similar to a forest. Here it's a forest plot. See on the extreme right side there, this is known as forest plot. So it's a line diagram for a forest plot. What this I just wanted to tell you, so that when you read it will be clear to you. Here this is an individual side effect. Either it will be in the form of a box or in the form of a dot. This is the individual effect size. This is for individual effect size of this particular study. See my cursor is this individual study effect size here plotted. This individual side data entered and effect side. These are all automatically generated graphs or plots. You keep on entering the data, it will automatically generate. So third study, this. Fourth study, this. And then this is the aggregated effect of all these studies. All these included studies. This is the aggregated effect. This is, or aggregated effect means pooled estimate. It usually take the shape of a diamond, known as, we call it popularly as diamond. Okay, because the shape of a diamond. Another thing here, you see that what is this line? This line is confidence interval. Pooled estimate, confidence interval of that estimate. Okay. What this line is? This center line is the line of no effect. Okay. Supposing here is odds ratio, this one. One is, what is the meaning of one odds ratio? Means there is relative risk 1 or odds ratio 1 means that is actually no risk, equal, both side equal risk. Okay. So similarly, there is negative effect on negative side and positive effect on positive side. So this type of a picture you get in this is a line diagram. Actually, you will see, then it will be easy for you to. Here, this is an example of a forest plot. So here, see, headache at 24 hours. This is the heading. So first column shows the identification of study. Okay, Amory Kofia 2000. So author name and along with the year or publication, some study ID is given. Then what is event? Event is caffeinated coffee. And total. Total means out of 31 people taken caffeinated coffee, event maybe headache. Here in this case it is headache. So here you will read like that, out of total 31% taken caffeinated coffee, 2 of them developed headache. Okay. And then comparator is decaffeinated coffee. Here, can you see my cursor? Decaffeinated coffee. This was the, here decaffeinated coffee is the comparator. So out of 34% taken decaffeinated coffee, 10 developed the headache. So this data you need to enter, okay, and weightage and everything, software will take care of this. Everything will be calculated by software, okay. Weightage and how much weightage, automatically software will give that. So similarly for each event or for each study, all the event and total a comparator and outcome of total event, what happened means outcome, and total number of subjects, everything will be, you need to enter this. And then when you keep on entering the data, and graph will keep on appearing automatically. You add this first study, this will appear. You add second study, this will appear, and keep on. And then at last you will get this diamond. Okay. So this, what this diamond is telling, is a decaffeinated, favors the decaffeinated coffee. So here, what else you need to know? This is the pooled estimate. Can you see my cursor? $1.38, okay. 1.38%, 1.38, it's the relative risk of taking this, relative risk of after getting decaffeinated coffee. Relative risk of getting headache. Okay, and this is the confidence interval. Lower bound, upper bound, and this is the confidence interval. So this is your outcome. Here for this is the value of chi-square, p-value not significant. Okay, p is equal to, this is for heterogeneity. Heterogeneity is not significant, means the data is homogeneous. Okay, overall effect is significant. In between both the groups, there is p-value is 0.08. Sorry, it's non-significant. Okay, p less than 0.05 is significant, so this is again non-significant. So this is the way, like here, from here you test for overall effect. This overall estimate given here, this data, this overall pool estimate, it will be your result of or pooling of data of all these studies. That's the I wanted to tell. Weightage automatically, you need not to bother, software will give the weightage. So here, and this is actually diamond is the outcome. Shape of diamond give you a visual impact. If this is if the length is more than breadth, then वो चपटा सा ऐसा दिखेगा तो पता चल जाएगा इसका कॉन्फिडेंस इंटरवल बहुत ज्यादा है. ओके, headache at 24 hours. Headache at 24 hours. Here again, another studies are over again given. Maybe one need to this go through these publications in detail in order to interpret. But what my purpose here to tell you about the diamond, about the individual study, these are the confidence interval of the studies. See, the more the confidence interval, see in this fourth study where my cursor is, the confidence interval is so much, and the weightage is given less as compared to other 9.7. Others are 17%, 30%. So this automatically take care by looking at the confidence. Always present estimate with a confidence interval that you already know. Precision point estimate is the best guess of a values. Confidence interval express uncertainty. This already you know, you already might have gone through all these statistics. And another important thing, if this include a null value, this outcome, this confidence include one in its range, then it again means the reading is insignificant. The value is insignificant. If the CI include the null value, rarely means evidence has of no effect. Effect cannot be confirmed or reported, but available evidence. You need to correlate with your clinical outcome also. So here is another example. I think by now you might be able to know about and read these things. These are individual study. These are individual estimates, relative risk, fixed effect model. Fixed means fixed effect. Mental Hensel test might have been used, 95% CI. This is confidence interval first study, effect estimate first study, relative risk first study. This is the pooled estimate. This is the pooled estimate. This is the value. This is the confidence interval. These are the weightages, antibiotic, event, total antibiotic and event, placebo and event. Okay. So here in this study, antibiotics are given and their placebo is also given. So antibiotic, you see here diamond is going clearly showing that antibiotics have better outcome. So you need all these things, you need to enter what outcome is. You need to enter in the software, and then while entering, while giving the output, the software give the labeling that you provide. What model you are using, why, whether meta analysis is appropriate or not, that you need to define in your protocol. Quality of meta-analysis. So preferred reporting items of systematic review and meta-analysis. This Prisma statement is there that contain 27 items. So that Prisma statement, when you go for publication of your paper, they ask the checklist of Prisma statement that you need to give, and then it's a very clear-cut defined list. You just need to go through, and that checklist you need to give. Moore's statement is a meta-analysis of observational study. This is another type of statement that is used to assessing the quality of the studies, observational studies. Ravement 5.3, 5.4 आ गया. Cochrane Q statistics based on chi-square. Heterogeneity. Heterogeneity. What is heterogeneity? Heterogeneity, from where we see the heterogeneity is also available. Heterogeneity. Chi-square, degree of freedom. I square is for heterogeneity. Here I square indicates the heterogeneity. It could be anything between 0 to 100. 0 means no heterogeneity, means these studies are similar. If heterogeneity more means then studies are more dissimilar. Example, in my study there was lot of heterogeneity. Sorry. See here I square is 30%. 30%. Still 30% heterogeneity is means that doesn't mean that it means that there is less heterogeneity among the study, and the result that you are going to get are from similar type of studies. Whereas for my study, this cervical this चलो वो तो बहुत पीछे रह गया. This is 51%, means more heterogenic, but still 51% is not that bad. Here is given heterogeneity score, it can 0 to 100, 25% low, 50% moderate, more than 75% is high. Effect model is fixed effect and random effect. When heterogeneity is low, we use fixed effect model, and when it's high, usually we use the random effect model. So that for a smaller p-value, this fixed effect model is used. For larger p-values, random effect model is used. So for narrow confidence interval, this fixed effect model is used, and for broader, random effect. First, we shall determine the summary effect estimate by using both fixed and random effect model. Then you decide what effect model you use in describing your results overall. Then another terminology is assessing publication bias. So reason for publication bias: preference of general editor to select those studies that are having interesting findings. So those who are not having uninteresting or negative, these remain unpublished. So to those who fund studies are more favorably likely to support studies that are large and have positive findings. Supposing a pharma company is giving you funding to conduct a study, so they will like you to have the positive result in favor of their medicine. So such type of things occur. If something is negative coming, they will not like that study should publish, and things like that happens in the medical research. And then investigators are less likely to publish smaller studies with ambiguous or non-interesting findings. Smaller studies are delayed in their publication and not therefore captured, because यहाँ से वहाँ भेजते रहते हैं, रिजेक्ट कर करके अल्टीमेटली जो है ऑथर वो कहता है छोड़ो अब नहीं पब्लिश कर. So these type of practical problems. So this is a consider limitation including publication and other bias. So this limitation is a very, very important part. When you are writing about your systematic review, you need to give the limitation of your systematic review, definitely. And if you go through the Prisma checklist also, there they have defined that you need to give the limitations. So that is a criteria that you need to define in your research paper. Strength of evidence, consider applicability, and write up and then publish. So for risk of bias graph, after risk of bias, funnel plot is also available from Revman or any other software like Stata also give. So what are the software that are used for this systematic review and meta-analysis? This Revman, Stata, and what are other softwares, Dr. Dharmendra? There is I'm forgetting the name. You can just Google it out and see what are the softwares. Easy Cal, something like that. Stat. And this is the area on the extreme left corner, lower extreme left corner. If you are getting no study over here, means that there is a risk of bias. Here also you should get a study, and then your graph should be in the form of a funnel shape, inverted funnel shape. So you need to find out that whether you are not getting why this corner is empty. So chances of risk of publication bias is too high if you are getting this type of funnel. So this is the definition: tendency of investigators, reviewers, and editors to differentially submit or accept manuscript for publication on the direction of strength of study finding. जैसे कि मतलब पॉजिटिव आ रहा है तो ही वो छापते हैं, नेगेटिव को छापते हैं. Okay. So Cochrane, previously known as Cochrane Collaborators, was founded in 1993 under the leadership of Ian Chalmers. It was developed in response to R.K. Cochrane call for up-to-date systematic review for all relevant randomized control trial in the field of healthcare. Because earlier it was seen that people used to conduct the clinical trial, so much of inputs, money, material, manpower going into that, and then there is no database. No one used that in medical practice. And again, whenever needed, the same research question came into picture, and then since there is no database, no such thing, so people again and repeatedly conduct similar type of clinical trial. That's why it was decided to have this type of collaboration, Cochrane collaboration for this, for the randomized control trial to make a to similarly up to date, to keep the up to date information. So this is the snapshot of the site, Cochrane. There are so many functions here. You can join the Cochrane. You can get involved by participating, connecting, learning. Learning platform is there. Training also they give online, offline, etc. There are so many things. You just go to Cochrane site. Cochrane library is there. You find various clinical trials and research studies. Various Cochrane groups are there. You can get involved as a member. There are for each and every, like for cancer there is a group, for gynae there is group, for maternal and child health. So many groups are available. You can join of your interest. So if you want to get your systematic review registered in Cochrane, it's a very difficult thing. You need to have area expert in your team. You need to have published good quality papers on that subject. Papers means primary research on that subject in which you want to conduct systematic review. I mean to say, if you have conducted primary study in a particular area, or your collaborating authors, then only you can join the Cochrane group. And then Cochrane helps a lot whenever you conduct Cochrane review. They help a lot in conducting the review. But even if you are not able to conduct it, you can participate. So in piecemeal, they keep on posting various work. Suppose someone is conducting some systematic review and he want to, a piece of work he want to not able to do, or he wants some help, so they keep on posting that type of work you can do, and then in this way you can collaborate with Cochrane and join Cochrane. So these are the example of some groups that I have downloaded. Review groups and network. You can join your interest. You need to write to them. Then Cochrane training, online learning, offline learning. You can just keep on searching what, and if something found relevant of your interest, you can join that. This is the Raman software. How this base of Revman software look like. Left hand side, there are so many things that we need to do here. Title, protocol, these you need to, once you do Cochrane review, you need to enroll your things, and then you need to use this software and enter this data. And so it's a self-explanatory thing, and you keep on then adding up the things, and then what all, see my cursor, all or graphs and figures, whatever I was telling, automatically interactive. You keep on adding the data and the graph will adding up. Once you decided, you keep on doing the things, then you will come to them. I just wanted to show you this. Then if you are not conducting a Cochrane review, you are conducting review of observational study, then Prospero is the site. You can register your protocol in Prospero. Before registering, you should know that whether it's registered, you need to make your login over here, and then you need to register your, and steps, everything is given, and it's easy to use, self-explanatory, but your protocol need to be strong. And then once you register your protocol, they will see, they will then review your protocol, and if they find it worth including, then they will register your protocol. And this, if you while publishing your paper, when you mention your Prospero number, it gives more weightage to the work. So this is the Prisma checklist. So there are 27 items, 28 items. So here everything is written. Identify the report axis. Means in title you have to need to include that this is a systematic review, meta-analysis meta-analysis or both. And then structured summary you need to provide, describe the rationale. So one thing is that all the items are given like any other checklist. Okay. And then here you need to define on which page you have given this particular, like hypothesis statement, problem definition, on which page you have given that. So this is the checklist which you have to provide with when you send your article for publication. So in conclusion, systematic review seeks to reduce bias to improve reliability, and meta-analysis, of course, is a pooling of the things, and there could be various limitations. Thank you.